Hello friends, we want to welcome you back to part 2 of this summit entitled Creation or Evolution. We want to welcome those who are here in person, and again we want to invite you to come down and take your seat. We'd also like to welcome those who are joining us once again across the country and around the world. We've got a wonderful weekend in store. If you're just joining us, I want to remind you of our free gift this evening. It is a book written by Pastor Doug, and it's entitled 14 Reasons Why Evolution Defies Logic. And this is our free gift. So if you'd like to receive it, all you need to do is text the word Creation 777 to the number 40544, and you'll be able to receive a digital download of the book. Again, that's Creation 777 to the number 40544. Now, as I mentioned a little earlier, this is our opening in our weekend on Creation Evolution Summit. This event continues tomorrow morning at 10 o'clock Pacific time. So we want to remind you about that. We have a full day, and those of you who are joining us, we start live tomorrow morning with Pastor Doug at 10 a.m. Our speaker this evening for our second presentation is Professor Walter Veith. Now, I'm from South Africa. Professor Walter Veith is from South Africa. I was a student at the time, and I remember hearing rumors that began to spread around about a professor from a very prestigious university in South Africa who was an evolutionist, but he had become a creationist, and it had caused quite a stir, as you can imagine, at the university, and that's how I was introduced to Dr. Veith. Well, of course, we've heard many presentations, and I think you have too. But if you are new this evening, if you've never heard of Professor Walter Veith, let me give you a little background information. Professor Walter Veith is a zoologist, he's an author, he's a speaker, known for his work in nutrition, creationism, and biblical exegesis. He obtained his Bachelor of Science and his Master of Science degrees in zoology from the University of Stellenbosch, followed by his PhD in zoology from the University of Cape Town. His academic career includes serving as professor as well as chair of the Department of Zoology at the University of Cape Town in South Africa. In the 1980s, following a series of personal experiences, and he might share a little bit about that, and in-depth studies, Dr. Veith transitioned from atheism to Christianity, eventually becoming a Bible-believing Christian. Following his conversion, he began lecturing internationally on topics including creation science, Bible prophecy, health, Christian living, and more. Dr. Veith has authored several books, most notably The Creation Conflict, which challenges evolutionary theory and presents evidence supporting creationism. His ministry, The Clash of Minds, and his Q&A program called What's Up, Prof, is popular with audiences around the world. His presentation this evening is entitled 10 Questions Regarding Evolution. Let's give Dr. Walter Veith a warm welcome.
Good evening, everyone. I'm here to bore you for the next 15 minutes. I heard tonight that Pastor Doug and our previous speaker were both atheists, and as you probably know, some of you, I was also an atheist. But I had a twist. They came from a Jewish background. I came from a sort of Christian background. But my twist was that I wasn't only an atheist, I was also a God hater. I hated God with every fiber of my being. Not because the God of the Bible is the problem, but the theology that is presented in the world out there paints a very distorted picture of God. And it is quite possible that when you are confronted with some of these pictures and the animosity that seems to emanate from God, that you can start to hate him. And so being an atheist and a God hater was quite an interesting combination. And when I was a lecturer at Stellenbosch University, And I did get my PhD from Cape Town University, but I was not the chair of zoology there. I was the chair of zoology at Western Cape University for about 15 years. Now, when I became a Christian, my life really changed. It became a nightmare. I'm hoping to wake up at some stage and realize that it was just a nightmare. But it is a radical change that has to take place when you switch from one philosophy to another philosophy, and my emphasis is on the word philosophy, because science and the science of origins are two totally different things. Science is empirical investigation based on experimentation. And yes, you have hypotheses, as we heard before, but the philosophy of origins is a totally different thing. Now, in our country, where I come from, people are generally very religious, and they believe in God. But when they come to the university, they are confronted with a totally new philosophy. And in fact, we have Christian organizations that are present at the universities that train students in the science of evolution so that they do not make fools of themselves as Christians later on. So in other words, they are literally, proselytized into believing the theory of evolution. We were never afraid of creationists. We loved them when they came around so that we could rip them apart and laugh at what they were saying. You see, the science that they brought was not necessarily wrong, because I believe a lot of that science today. But it had to be ridiculed purely from the basis that it had to be wrong. Why? Because there was no God. And if there is no God, whatever theory you come up with on origins, it has to be wrong, because it has to be naturalistic. There is no God. And so when a theory runs into trouble, then you have to find solutions for that trouble, and you have to change your approach, but the basic premise is there is no God. And if he were there, you'd hate him anyway. And so I was often confronted in my lectures, because I used to lecture on evolution. I was a committed evolutionist with young students that would say, "Excuse me, I believe that God created this world." They would never get any further than that sentence, because you would destroy them, ridicule them. And I've had students burst into tears, and I'd feel pretty good about myself, having destroyed their little childish philosophies about some deity out there. Can you imagine a world like that? Many of you probably can't. Well, when I changed my view, I had to find a new foundation. Where was I going to get that foundation? I didn't have the facts at my fingertips as I would perhaps have them today. And so I was confronted with the situation where I had to present a class, and I could either stand there and pretend that no change had taken place in my mind, or I could face my fears and my colleagues and ask a few questions. And that's what I did. I asked questions. I didn't actually present any answers to those questions. I just asked questions. And to the best of my knowledge, I had 10 questions. Now, this was some 38 years ago, so I'm not absolutely sure whether these questions were the ones that I asked, but the essence was more or less what I will be talking about today. 10 questions that I presented, and the result was pandemonium. Pandemonium. I never even supplied any answers to those questions, but the result was pandemonium. Not only pandemonium, but vicious anger, such as I had seldom seen in my entire life. And the consequence was that a young girl got up after those 10 questions and accused the lecturers, saying to them, "When I came to this university, I believed in God, and you have destroyed my faith. And now I can see that you duped me." Now, all my colleagues were basically atheists. But some of them actually went to church and were elders in churches, but they were atheists. I don't quite know how that works, but Richard Dawkins recently in an interview said that he is an atheist, but he considers himself a cultural Christian. Because the alternative, the other religious views out there, were, in his opinion, worse. But when you read his book, that he writes about his view on God, the God delusion, he actually points out that he hates God. And the strange thing is, he hates God for the same reasons that I hated him. This vindictive deity that shoves you into hell and roasts you for all eternity on the basis of a short life, which in terms of eternity is non-existence, was rather cruel. And this was the reason why he rejected it, same as I did. So let me run through these questions before they kick me off the stage. In Exodus chapter 20 we read, "In 6 days the Lord made heaven and earth, the sea and all that in them is, and rested on the seventh day." Now you tell an atheist that he must rest on the seventh day because God created the world in 6 days. Do you think that'll go down well? Is it even logical? Why would you want to keep one day in commemoration of creation if there was no 6-day creation? That wouldn't make any sense whatsoever. That's sort of a disconcordance in your mind. And try and get your head around that one. But that is exactly what the Bible says. Now, can something like that be true in the face of all the science out there? Well, I posted these 10 questions. Let me run through them for you. If the evolution of life started with low diversity, and diversity increased over time, why does the fossil record show higher diversity in the past and lower diversity as time progressed? It's a simple question. And it's a known scientific fact that if you go back into the paleontological record, there are far more creatures out there than we have today. So we seem to be losing species at an incredible rate. And that loss is continuing to this very day. As we speak, species are going extinct on this planet. And yet you have to ask yourself the question, how is it possible that it had to start with low diversity, but when you go to the paleontological record, you see the opposite. You see zillions getting less and less as we go along. It's the reverse. So that's the first question. The second question I posed was, if evolution of necessity should progress from small creatures to large creatures over time, why does the fossil record show the reverse? It's just a question. I mean, it's logical, right? You don't start evolution with an elephant jumping out of a pool. It doesn't happen that way. You start off with a unicellular creature. It must be small in the beginning and then it must increase in size. But if you go to the paleontological record, everything was bigger and larger and more wonderful. They must have all come from the United States of America. than they are today. So what happened? So let me show you some size comparisons. This is an artist's view, but it's pretty accurate. And it appeared in a scientific publication, so let me show it to you. There on the left, you have the sloth, the ancient giant sloth. And clinging to its side over there is the modern equivalent. Would you agree that that is quite a reduction in size? I think so. Now, obviously, this creature lived millions of years ago, until in South America, in a cave, they found intact pelts. In other words, the skin of the creature intact, with that size. So that put the cat amongst the pigeons. Or what about the wombat there on the right, with its modern equivalent at the bottom there? That's quite a reduction in size. Is this evolution or is this devolution? Are we going forward or are we going backward? Or the lion, or the orangutan, the size difference between the fossil and the present one is pretty dramatic. Or the capybara on the left there, or the armadillo on the right. The big one is the fossil that you find, and the other one is the modern day equivalent. Or the horse, or the shark. If you want to really see how big those sharks were, look at that picture on the right, and on the left there is one tooth. That's pretty big. They would use a modern great white as a toothpick. So what has happened? Was it a weird and wonderful world that existed in the past? Did something strange happen and, it just deteriorated to what it is today, or the bison or the crocodile or any one of those? The third question, and this gets a little bit philosophical, natural selection works by the elimination of the weaker variants. So how does a mechanism that works by subtraction create more diversity? That's a simple question. Let me try and unpack that a little bit for you, and we'll unpack it more tomorrow. But this is the heart, the driving force of the evolutionary theory. So you have these variants, and then over time, through natural selection, one is favored over the other. We call him the fitter, and the other one the less fit, and eventually the fitter one replaces the other one. So you started off with 2 variants or 3, and you end up with fewer variants. So the question is, how does this mechanism that makes less and less over time manage to create more and more diversity as we go along? Isn't that a logical question? Okay. So how would we consider Darwin's finches, for example, and all those variants that evolved over time? We know they exist today, so what happened? We'll go to that tomorrow. The fourth question is, why do the great phyla of the biome all appear simultaneously in the fossil record? This is a bomber. And even in the oldest fossil records, namely those with the macrofossils at least, the Cambrian, why are they there all of a sudden? Now, I don't know whether you are familiar with what a phylum is. Are you? Anybody not know what a phylum is? A phylum is the largest category of similar creatures that exist. So the animal kingdom is divided up into phyla. So we belong to the phylum Chordata. That's anything with a backbone type structure, whether it is made of bone or of cartilage or of fibers, doesn't matter, as long as it has a rigid sort of rod in the back, and I have one here. You belong to the chordates. And then you get the arthropods. They have a skeleton on the outside. Anything that has that, whether it's an insect or a crab or whatever, it belongs to that phylum. It's huge categories of creatures. Now the question is, how can these phyla appear simultaneously? Because logically, in the evolutionary process, one form evolves into another over very long periods of time, and they should be appearing sequentially in the fossil record. It's impossible to imagine that they can all appear at the same time. So whether you're talking about insects or crustaceans or annelids or mollusks or roundworms, let's take the phylum Mollusca. Anything from a squid to an octopus to a snail to a slug to a marine-footed creature, they all belong to that. It's a huge category of animals. And that, plus all of these others, appear suddenly and simultaneously. They call it the Cambrian explosion. And if you go to a document like Scientific American, for example, they talk about the phyla appeared almost simultaneously. They're lying because they put the word almost in there. Because they don't appear almost simultaneously, they appear simultaneously. That's mind-boggling. How could this have happened? And so they comment that fast turns out to be much faster than anyone ever thought. It's almost like somebody said, let it be, and there it was. And then they have this document over here where they claim that older textbooks proclaim that our phylum, that we belong to, the chordates, must have appeared very late in the evolutionary process. But oh, troublesome, troublesome science. They're there in the Cambrian explosion. In other words, they were there from the beginning. Now that must radically change your thinking. You must rethink your entire science. But there's no God. So you leave him out of the equation. You have to find a solution to this problem. And then you have another problem, that is there are no intermediary fossils. So how do you deal with it? So the fifth question was the following. Why do we have to postulate punctuated equilibrium to explain away the lack of intermediary fossils when gradualism used to be the only plausible explanation for the evolutionary fossil record? Did you all get that question? Well, you know, my colleagues, they varied in age. And the older colleagues were all, well, we were all Darwinists, because we were evolutionists, but the older colleagues were gradualists. Now, that's a nice word, gradualists. What does that mean? That means you believe that life evolved over long periods of time and gradually changes took place so that one form gave rise to another. That makes sense. That's Darwinism at its very basic core. Gradualism. And it's the only logical way to conceive of an evolutionary process. The only logical one. But unfortunately, that would imply that if gradual change took place, you should find the gradual intermediaries. Doesn't that make sense? I mean, something that looks like a cow that evolves into something that looks like a whale must have something in between, right? What if it's not there? Well, then you have to rethink gradualism. And so Stephen Jay Gould came up with the idea of punctuated equilibrium. It's a beautiful term, which means the following. Long periods of no change, no gradualism, equilibrium, and then punctuated, rapid change. so rapid that there's no record of it in the fossil record. That's a fact. Now, the younger colleagues at my university, we were all punctuated equilibriumists. The older ones were clinging to the hope that they would find those fossils. So they were gradualists. So we had a lot of arguments back and forth, who's right, punctuated equilibriumists following Stephen Jay Gould, or old-fashioned Darwinists, who's right? But the basic premise was always, somewhere there must be an answer because there is no God. Did you get that? All right, so we have to postulate punctuated equilibrium. In other words, the mere fact that modern evolutionists by nature are punctuated equilibrianists is an admittance that gradualism cannot be right. Because then you would have to find the intermediaries. Why would you have to change your a priori assumptions in order to accommodate the theory? Because the facts don't match the theory. Good. That caused quite an interesting debate. Can you imagine that? The sixth one. If natural selection works at the level of the phenotype and not the level of the genotype, then how did the genes, mitosis, meiosis, with all their intricate and highly accurate mechanisms of gene transfer evolve? Did you get that one? All right, let me unpack it for you. Natural selection doesn't read your genes. It couldn't care less about your genes. Natural selection only cares about what you look like. Are you a giraffe with a long neck or are you a giraffe with a short neck? I don't know why a short neck shouldn't work as well, because there's lots of things to eat down there anyway, but don't worry about that. The fact of the matter is, natural selection only cares about what is physically there. All right, two people are running. One has got very short legs, another one's got very long legs. Who do you put your money on if you take a bet? Because who's going to win? The long-legged one, right? That's his appearance. That's what he looks like. And that we call his phenotype. His phenotype is what we actually see. So if I describe any one of you, I would be describing your phenotype. I would not be unraveling your genes and telling you what your DNA composition is like in order for you to look like what you are looking like. Natural selection doesn't read. It can't read your genes. It can just read the result of your genes. Does that make sense to you? All right, so here's the question now. If this is true, that natural selection only works at the level of the phenotype and not the level of the genotype, and there is no Darwinist who won't agree with that fact. It's an axiom. It's logical. Then the question is, how did the intricate genetic makeup and the possibility for cells to divide and still maintain their integrity, how did it come about? How did the genes evolve if natural selection doesn't care about your genes, but only about what the result thereof is you? How did it come about? Or how did meiosis develop? Where you actually halve what you have and share with the other partner and mix it up to make a new variant, which is called your child. How did these things come about? Well, the only logical answer that you have then, because natural selection doesn't work at the level of the genotype, it cannot, is that it had to come about by chance. All right, let me make this a little more simple for you then. So your phenotype is that little man there on the right. That's what you look like. And yes, you are the result of your genotype. But natural selection doesn't know that. So it only worries about the phenotype. So all your genes that code for your phenotype, how did they come into existence? Natural selection had nothing to do with it. Had to come about by chance, random chance. Rewriting and rewriting, you know the old story in the books about how many monkeys need to be typing randomly to get the Encyclopedia Britannica, and all of those ideas that they put out there. Well, eventually they say they will. They never will. They never will. They might get a word, but will they get it in the right sequence? And your DNA molecule is far more complex than we knew when Watson and Crick decoded the DNA molecule. It's far more complicated than that. So how did all of these things come about? And how did these reactions come about? Let me unpack it for you a little more. Your phenotype, in this case, is your aeroplane. And your genotype is the engineer's book on how to construct that aeroplane. Are you with me? Yeah. So natural selection will want to see whether this phenotype, this aeroplane, is any good. How good is it? But that's not going to work unless you have two aeroplanes. Because selection implies that there's something to choose, right? And I understand that the United States is now building a new fighter jet that is supposed to outstrip the powers of the Chinese jets. Is that correct? I just heard that this project has been given to Boeing. That seems to be struggling because I flew here on an Airbus. So maybe that'll help them. So the natural selection is going to be which one flies best, the USA new prototype that Boeing's going to build, or is it the Chinese model? That's selection. You need two of them. Are you with me? All right. So which one is going to fly best? That was the question. Let's go back to that one. So engineers have been working round the clock, and apparently this prototype, as I've read in the news, has been tested now for some 5 years, and they're ready for production. You probably all know about these things, right? My question is, who wrote the book? Who wrote the book? It's not a stupid question. Some engineer wrote it, right? Or a bunch of engineers wrote it in great detail. But it's genotype, it's a book. All right, I have a book in the front here. I see here's a book. Here's a book. Let's say it's got all the information for that particular aeroplane right here in this book. Everything is here. Everything that scientist and that engineer, in all his ingenuity, in all his years of training, managed to put together, he put into this book. Let's put the book down there and let's wait for the aeroplane to appear. What's funny about that? How long am I going to wait? Are you sure? Yep. But all the information's here. And who wrote it? Well, when it comes to naturalistic science, who wrote it? Who wrote the book? Who wrote the blueprint about what you're all about? Who wrote it? Oh, well, you're a believer, right? There is no God. There's no God. That's ludicrous. That's childish fairy tale. Who wrote the book? Chance wrote the book. Chance wrote the book. There is no other alternative because there is no God. We can't allow a divine foot into science. That would not be naturalistic then anymore. That would be supernatural. There is no God. So whether it works or whether it doesn't work, whether it's probable or whether it's not probable, it doesn't matter. Chance wrote the book. My next question. The process of crossing over during meiosis is an extremely sophisticated mechanism that requires absolute precision. How could natural selection bring this about if it can only operate at the level of a phenotype? I don't know whether you were involved in biology courses. Did you ever, who studied meiosis here? A couple, all right. Meiosis is an incredibly precise operation. Because in meiosis, you have to halve the number of chromosomes, and you split them into what you got from your father and what you got from your mother. And then you pair them up with your partner's chromosomes. But before you do that, there's a process of crossing over, where certain genetic material that you got from your father is crossed over to the genetic material that you got to from your mother and vice versa, and it has to be absolutely precise. If you cut that gene that is crossed over in the wrong place, just one little letter further than it should, the whole thing becomes drivel, garbage. And you won't have children, you'll have cabbages or something similar. No mistakes. And yet, through the very process, I can with confidence say to you tonight that if I said to you, will the two that are absolutely identical in every aspect please stand up in this hall? Nobody would get up because you're all different. That's why by looking at each other, we can give each other names and not get confused because we're all different. We're all unique. Because we have this tremendous variability that has been built into the process. How did this mechanism come about? And it is so amazing. There may be no mistake. They even give the enzymes that are involved in this activity certain names. So you have transcription enzymes that run along and make an exact copy of whatever there is you are copying. But to make sure that there's no mistake, because you don't want cabbages, you want real children, you have another 5 enzymes running after them that are called editases. That's a nice name, because they edit. Clifford Goldstein is an editor. You should know what that means. It means you go through the script to see if there's something wrong and you fix it, right? And that's what they do. They make sure there's no mistake. That's why humanity can still exist, although we are, believe it or not, greatly deteriorated. Because as we said before, everything was bigger and better and larger and greater and more superb than they are today. So this magnificent process is not subject to natural selection. Only the result thereof, what I see in the offspring, is subject to it. So how did it come about? Can you see the wheels turning in those students, postgraduate students and my colleagues? So there are your chromosomes. 23 pairs, one from your dad, one from your mom. They line up like that, and then they start switching material. Hundreds of thousands of times they cross them over, so that you are a little bit of dad and a little bit of mom and a little bit of mom and a little bit of dad. And the result is whatever it is. And grandma comes and says, "You look just like your father." And the aunt comes and says, "No, no, no, I just see the mother." Isn't that true? Isn't that what happens? How do they come about? It's amazing. And so let's say the blue is dad and the red is mom. And you do that 100,000 times, and you have to do it absolutely accurately, or else nothing works. That is a phenomenal event. Question number 8. How can we explain the evolution of two sexes? Now I'm on dangerous ground, because I don't know which pronouns to use now. But fortunately, your president said, "No, we only recognize two, so I'm okay." So how can we explain the evolution of two sexes? With compatible anatomical differences, when only the result of the union, increased diversity in the offspring, is subject to selection, but not the cause. Just think about that for a while. Now that little amoeba, or whatever it was, that first protozoan, only had no sex. There was no partner. And then for millions of years, these protozoans increased, and natural selection sorted them out until there were none left. No, I'm sorry. Somehow magically increased the diversity, although it should have reduced the diversity. And here they were, swimming in a soup. And eventually they got stuck together. We'll talk more about that tomorrow and how it all came about. But there weren't two sexes. They didn't exist. Now, two sexes is a very serious issue, because then in order for it to work, you need to have meiosis, right? We just spoke about it. Because if I have 46 chromosomes and there was no meiosis, and my wife had 46 chromosomes, how many chromosomes would my offspring have then? It would become intolerable, right? Become more and more and more. So now we have to keep it at 46, so let's, halve them down to 23 and 23, and then mix it up and all of that good stuff. But the two sexes, how did they come about? What is the aim, according to science, of having two sexes? What is the aim? Why does science postulate that the evolutionary process had to eventually introduce sexes? The answer is to increase diversity. That's the answer. You have to increase diversity, because natural selection does what? Reduces diversity. It works on the basis of subtraction, not on the basis of addition. All right, so how magically did they come about? Boom! One day they were there, like the Cambrian explosion. Wow, is that Eve? Is that how it happened? Because natural selection won't do it. And then, if you haven't noticed, they're anatomically different. I don't know about the bathrooms and the stuff now, let's not go there. But they are anatomically different. Thank God they are. Question, how did it come about? Chance or design? That's the question. I have 2 more questions for you. Do you realize how much anatomy and physiology and hormonal differences and all of these issues are involved in this process? It's mind-boggling. And to believe that it came about by chance, without natural selection actually being involved, because only the result of the union, the increased diversity in the offspring, can be subject to the selective process. It is mind-boggling. So any modification in the genotype to bring about changes in the phenotype occur by chance through mutation. So all of these things happen by chance through mutation. Now we're going to talk about that some more tomorrow when we talk a little bit more about the genes. Now we only have 50 minutes, so I don't have time to give you the answers, I only have time for the questions. So this whole issue of fertilization, independent assortment, crossing over, you know, these are incredible mechanisms. Can you imagine unraveling a DNA molecule to make a duplicate? Have you ever envisaged a rope that is twined, two pieces entwined and twisted together? And you're going to open them up. So you hold the one end and I'll hold the other end, and let's open them and pull them apart to see what's in the middle. What happens as we start pulling them apart? They get tighter and tighter in the middle, right? Until we can't pull them apart anymore. I'm going to read the genes in the middle. How am I going to do that? Because it's a helix. It goes round and round and round. How am I going to twist them apart? Do you know that there are enzymes that clip onto certain sections like ball bearings and go so you can read the next bit and then go tick, 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 tick. Put them together again in the right sequence so that you don't become a cabbage? Can you imagine that? How intricate the process is? It's mind-boggling. I could give you a lecture of many hours on how that works. It's amazing. And chance did it. The next question, number 9, was the evolution of molecules of life all require totally different environmental conditions to come into existence. Without enzymes, and some have never been produced under any simulated environmental conditions, why do we cling to the explanation for the origin of chemicals of life? Let me make this simple. Moreover, the reactions that have been simulated produce left and right-handed molecules, but life can only use left-handed racemic molecules, and there's no random mechanism that allows for this. So the early atmosphere would have had to be a reducing atmosphere, devoid of oxygen. But if water is essential for evolution of life, then in the absence of ozone, cosmic rays would enter the atmosphere, and they would denature water, and that consists of hydrogen and oxygen, so there would be oxygen. So we have a problem. So Stanley Miller is the one who came up with this experiment, where he put a primitive atmosphere into a chamber, closed system, passed sparks through it, and then isolated certain organic molecules and said, this is how life started, by creating these molecules. And this primitive atmosphere consisted of hydrogen, ammonia, carbon dioxide, methane, nitrogen, and water. Volcanic gases are not reducing atmospheres because they contain sulfur dioxide, for example. And the present atmosphere has oxygen. That would never work, because as soon as the molecule is created, the radiation destroys it. So you can never get a molecule unless you have a closed system, and there never was a closed system. But there's another problem, the left and the right. So let's say you create amino acid. Some of them have never been created by any experiment. But let's say you create amino acids and you have left-handed and right-handed ones. If you want to know how that works, then just lift up your hands like this and look at them. They're mirror images of each other, aren't they? So left is where your thumb is on the right, and right is where your thumb is on the left. Correct? Whatever. So these are mirror images, and the same with molecules. They are mirror images. And mirror images have to be selected. The left-handed ones are called L, and the right-handed ones are called D, and you can never put one D into a protein and have a functional protein. It wouldn't work. So naturalistically, you could never get a protein that is conducive for life. How did it come about? How did you do it? And once you want to do the nitrogenous basis of your DNA structure, you need a different atmosphere. And so scientists has grappled with the idea. We don't have to go into the details. We only have 4 minutes to finish this. How do they come about? Well, you need different atmospheres in different situations. Maybe there were different situations on the Earth where it could have happened. And then scientists will say, but it couldn't have happened here. It can't. You can't have all these different scenarios to create these molecules naturalistically. So where do they come from? So they come up with the idea called panspermia. Nice name. Which means it came from out there. And it spermed this world. It came from outer space. It can't happen here, it must have happened there. Is that a solution? If it can't happen there, why can it happen out there? Yes, it's not as easy as the textbook seems to imply. Get a couple of molecules. Ooh, this is how it happened. But you can't get the rest of them. It's very complicated. The last question. How do we explain irreducible complexity if the probability of any of these mechanisms come into existence by chance? What is irreducible complexity? It's a term Michael Veith came up with, and it's a very good one. Let me give you an example. Here's a scientific publication. If I had to read it to you, you'd probably go nuts. And so I'm not going to read it to you. On one of these problematic structures, and that is the flagellum motor. The flagellum motor of a bacterium or of a human sperm cell, for example, has a flagellum, and it has a motor that drives it. So it's this filamental tail and this structure that is inside the cell wall, and it looks roughly in the cell wall like it does there on the right. And these are all protein kinds that work together to make this thing work. And it's a highly complex structure, and it has to be absolutely complete, or else it won't work. So in E. coli, for example, and you have millions of them in your gut right now, they're all swimming around in your gut using this motor. The ones on the left use a proton motor using hydrogen, and some bacteria or organelles use the one on the right, which is a sodium-driven motor. Now these motors are amazing because let's take a sperm cell. It has to swim through the medium to go and find an ovum. And sometimes it finds an obstacle, and it has to increase the power and the torque to get over the obstacles. It goes over it and bumps into something, and it has to put it into reverse gear and try another route. It's got a forward gear, it's got a backward gear, it's got an increased torque. It's better than the Jeep that I've just gotten at the airport to drive here. And it's irreducibly complex. In other words, it's either all there or it doesn't work. Let's call the left one a gasoline engine and the one on the right a diesel engine. And if you take the pistons out, they don't work. They're irreducibly complex. What about a chloroplast that is the basis of the food chain that supplies all of us and all the animals in the world with food? It is an irreducibly complex structure. And the result is that you put water and carbon dioxide and light into the process, and boom, what comes out the other side? Sucrose. That's amazing. Nobody has ever been done that. Who's ever stuck a stick into the ground and got maple syrup? And man, we would be wonderful if we could do that. Man, why don't we think of it but shove a stick in the ground and get maple syrup? Should be possible. So my 10 questions. Thus the heavens and the earth were finished and all the host of them. Is it plausible or is it not? That is the question. Let's pray. Heavenly Father, science does not have all the answers. Your book supplies many answers that are in contradiction with science. And the God that is described in that Bible is described as a God of love, and yet the world teaches that you are a tyrant. What a dichotomy of thought. Help us to cut through the noise to find the God that is a God of love, that was prepared to give up heaven, to die to redeem sinners such as us. Help us to find Him, is my prayer in Jesus' name. Amen.
Thank you, Dr. Veith. Just to remind you folks that we are going to continue our Creation Summit tomorrow morning. It's at 10 o'clock. Pastor Doug will be sharing a caveman's view of evolution. So that's going to be at 10 o'clock. Just looking at the group that's here in person this evening, if you don't come early, you might end up in overflow tomorrow morning, all right? So bear that in mind. If you can carpool with other family members, parking is going to be very much in need tomorrow. So if you can come as a family or bring the same car, that will be helpful. God bless. We'll see you tomorrow at 10 a.m. and God bless to those who are watching. We'll see you then.